On this bell work, we see the function f of x equals 3 to the power of x plus 1. So we have to use the exponent button on this one. But down here it says find f of 4. This means that we're solving when x equals 4. Okay, so we're going to take that function, f of x, let's go and rewrite it. F of x equals 3 to the power of x plus 1. But again, I'm going to take that x and I'm going to replace it with 4, just like it tells us it is over here. That means all the x's in the function get replaced with 4. So that exponent of x gets replaced with a 4. So just as a quick reminder how to put this into the calculator, of course, you're going to type in 3. That's our base. Then we need an exponent of 4, so we're going to push this exponent button. It's one button above the divide button on the right side of the calculator, and then I push 4 because that's my exponent. Now I've got to get out of exponent mode, so I got to push the over arrow to the right, and then I'm going to push plus 1, then I'll push enter. And when I do, it tells me what the answer is here. Looks like it's 82. So f of 4 equals 82. That's it. Two objectives for today. I can find the domain and range of graphs, which we've seen domain and range already. Okay, we've done it with list form and then some interval form. And also I can determine if a graph is increasing or decreasing, which we've seen already, positive, negative, or both, and then either continuous or discrete. So continuous or discrete down here at the bottom, this is new for us. But increasing or decreasing, not new. Positive, negative, or both, still not new. All right. So things are going to be a little bit different. So we may see some exponential graphs, meaning they curve, but they're going to curve a little bit different this time. Take a minute, copy this down. That way we know what we're trying to learn, and then we'll get started. So it's important to remember that when we look at domain and range, domain is from left to right. And then range, since that's our y values, that's low to high. So remember on graphs, you have two axes. You've got a horizontal axis, which is the x-axis, and then you got a vertical axis, which is the y-axis, okay? So these are just two number lines that have been pushed together. And so x, since it's horizontal, that's left to right, domain. And then the range is the y value, so that's, oh, thank you, very good. So the range goes from low to high. So you start from the bottom going up, you say down going up, whatever you want to put there. I put low to high, it's up to you. But again, that's because the y-axis itself is vertical right there. All right, now the difference, what we're going to see today is, it's nice when we see, like we're going to see on the next graph, is it's going to be just a bunch of points. And when we list these, and it's just a bunch of points, then we can list them in set notation. So remember to open up a set of fancy brackets, which we were going to need to list these values. You make an S, then you got a 2. And we consider that fancy enough, fancy brackets. And then to close them, you got a 2, then you got an S. Boom, closed fancy brackets. And then you just put whatever values you need in between. This is good when we're listing values, but once we get into intervals, then we're going to need to change that just a little bit. So here this one takes us back, find the domain and range, but again, it's just a bunch of ordered pairs on there. Now, if you wanted to list the ordered pairs, you could. For example, this one right here, this would be, looks like -3, -4. I was looking for the numbers on this number line here, but it looks like they've listed them down here. Okay. I don't know why they've done that, but they have. Same with this one on the left. Either way, it doesn't really matter. And then we look at this point right here. This one would be, looks like -2, -4. And then this one, 0, 1. And then 1, 1. And then 3, 4. And then also 4, 4. So these are the ordered pairs that I have. And if you need to list them like this in the beginning, so be it. Not every student does. So I just did some work some of you may not end up doing, and that's fine. As long as you remember that the first value in each ordered pair is an x value, and then the second value is the y value. Okay? So x values, again, you're looking at your horizontal number line. Y values, you're looking at the vertical number line. Now notice it's not asking if it's a function. which we could do. We could do the vertical line test on this one, and it would pass, by the way. This one will pass the vertical line test. So it is a function, not that we care. What we are concerned about first is domain. When we list these, since we're listing each individual value, we need fancy brackets. So I've got an S, then a 2. Fancy brackets. Now, just like we have in the past, I think this assignment wants these listed from least to greatest. So I'm going to go from left to right for domain, because left to right would represent my X values. So the furthest point on the left I see is this one up here. So that's an X value of -3. I don't care about the -4. That's in the range, not the domain. But the first value on the left I see is -3. As I move to the right, the next one I see is -2. And then I have an X value there at 0. And then 1. And then 3. And then the last one we have up here is at 4. Now, if any of the X values repeated, then we know that it wouldn't be a function. But I would not list any repeating values if there were any. But there isn't, so I can list all of them. That is all of them. So now I can finish this off with some fancy brackets, a 2, then an S. Boom. So that is my domain. So now that we have that, let's go ahead and list our our range. Sorry about that. The range is going to be all the Y values listed. And since I'm looking at my Y values, I'm going to start from the bottom and go up because I want to list these from least to greatest. Because I believe you will have to do that on the assignment. So to start my fancy brackets, I got an S, then a 2. Bam, fancy brackets. And so I'm starting at the bottom and then working my way up. At the bottom, we've got a Y value here of -4, but this one also is -4. I do not want to list it twice because mathematically, math people are lazy, so we don't want to do more work than we have to. So the first value I'm going to list here, the one at the bottom, the Y value is -4. The next Y value that I have moving up will be with these 2 points, and that has Y values of 1, and it's the same 1 right there. So again, I'm not going to list this more than once in my range. I'm only going to list it once, is 1. And then finally, we get to the 2 points there at the top. Again, they have the same Y value of 4. So comma 4. That is all the Y values I have. Again, all 3 of these repeated. So there were technically 6 Y values, but we don't list them repeating, even though we have 6 total X values. Last thing I need for my range is to close my fancy brackets. So a 2, then an S, bam. That is the domain and the range. So you could think, right, if you were to make a mapping of this, you'd have in the left column, you'd have all these values, but then you'd have arrows from -3 pointing to -4, and then -2 pointing also to -4. Same with 1 and 0, 0 and 1 pointing to 1, 3 and 4 pointing to 4. Okay, so again, I guess that's just kind of stuff we've reviewed or seen already, so it is a review. But you could make a mapping if you wanted to. So for this one, it shows a range of solutions for an inequality, whatever. We're not concerned about the inequality. Don't worry about that first sentence, all right? But what we are concerned about is, this is for graphs, okay? So we're looking at interval notation. We need interval notation once we see a line on the graph, because the last example that we just did is just a bunch of ordered pairs. We can list the domain and range as separate values. That's nice. The problem is once there's a line, no matter how big it is, okay, so even if the line is just very short like this one, if you got 2 endpoints like this, automatically there's an infinite number of values that stretch that point between those 2 points. And the reason why that is because these decimals in between the points, they can get as small or as big as you want to say it is. I would say small. You can get values that are extraordinarily small in there, okay? So there's an infinite number of values, which is why an interval is a nice way to demonstrate the values that work in your domain and range. So for our domain, we work from left to right. Range is down to up. The main thing on this one is that we see that it's possible for some of the values to go from -infinity to, or even it may use positive infinity, both for domain and range, all right? Now the infinity symbol, this goes back, but the infinity symbol to me is just an 8 on its side. And this would be positive infinity. It's possible to have negative infinity, which is just the infinity symbol, but it has a negative sign in front. That's it. Okay, so this one's negative infinity, this one's positive infinity. Now the unique thing about infinity is it's such a large number, mathematically speaking, no matter what math nerd you talk to, it's so large they can't quantify it, which is why we have a symbol to quantify it. And in fact, it's actually getting bigger as we speak. So infinity is too large to use, so we have to use parentheses when we use infinity. Okay, so this is the new part for us when we speak about domain and range, is that now some of our domains and ranges could go to negative infinity, some of them could go to positive infinity, or both. All right, now if they do, they tend to use arrows on the lines, which we will see today. But again, we will use parentheses if a value is included. We will use square brackets if a value, I said that wrong. We'll use square brackets if a value is included. We'll use parentheses if a value is not included. That's what this is saying right here. So that brings us back to this slide. Again, square brackets means that we have a closed circle, which means it is included. That's this part right here. Other values that are included, we may use square brackets if at the limit of either left or right or bottom and top is on the line. So if we're looking at values that are on the line, then we use these square brackets. Now that may not make sense right now, but we'll see examples that do, hopefully. On the other hand, if we use parentheses like these ones, then that means at the ends we have open circles, whether it's bottom and top, left and right, or if values go to either negative infinity or positive infinity, like this. Okay, because again, infinity is never included because it's a value that's so large we can't quantify it, and it's getting bigger as we speak. So we have to, since it's changing, we can't say that it's a specific value, meaning we have to use parentheses for that value. All right? So again, the new parts for us, maybe a little bit of this. Maybe we'll see values that are on the line where we're using square brackets. Maybe it's just going to infinity or negative infinity, so we got to use parentheses. We'll see. So this one, we've already seen graphs like these. So the domain, again, that's x values, which means we're looking at left to right. Now this means you do have to go from left to right. You start as far to the left as you can go, and then see how far to the right you can go. So to the left, I see the leftmost point is this one, which is a closed circle, so I've got a square bracket there. So my domain, I'm going to put a square bracket, and that x value that's showing is negative 2. So the x value that I start with furthest on the left is negative 2. I have a square bracket there because it's a closed circle, which means it's included in the domain. Now, as I go to the right, I don't care that it goes down, by the way, but I just go to the right, and then I see it ends at this point, which is open. It's okay that it's open. It just means that the furthest point to the right is not included. So I have to use a set of parentheses right here. So I can put in my parentheses. You can put the number in first if you know what it is. Make sure you put a comma between the two values. But the domain, as an interval, tells us we're starting at negative 2, and we're going to go all the way to, let's see what that value is. So we'll just follow this down to the x number line. Looks like it stops at 5 for my x's. Okay? So that is my domain. And it means that all the values in between are included, whether they're rational or irrational, whether they're decimals or fractions. Doesn't matter. Starting at negative 2, which is included, and then stopping at 5, all the values in between, even including 0, would be in my domain. All right, let's go to the range. The range, of course, is our y values. And that's our vertical number line, which means we're going to go from down, or the bottom, to up. I don't know. That sounds weird. But either way, I'm just looking for the lowest point, and then I'll work my way up. So the lowest point I see on this line would be this one here. Oh no, it just happened. There we go, this one. Okay. So that's an open circle again. So going up, I'd have a set of parentheses there. So I'll start with a set of parentheses. And that y value, so I got to follow this over to my y-axis to find that value. It starts at 3. Now it's moving up. So starting at this point, I'm going to move up, and the highest point that I have is this one. So that's a closed circle. which means I'll have a square bracket right there at the very end of this. There's my comma, and that y value, I mean, you could follow it over here, but either way, that y value is 4. So it's a much thinner range than the domain. It doesn't matter. These numbers, they're consecutive. That doesn't matter either. Sometimes they're positives. Sometimes they're negative and positive, like this one. Doesn't matter, all right? So you're just going from down to up for your range, left to right for your domain. But this right here is the interval. So we need the domain and range on this one, but notice this has arrows at the very ends of these. Okay, so domain, still in x values, which means we're going to go from left to right. Okay, so the leftist most point that I see is this one right here. Okay, right at the tip of that. That's called the vertex, not that you care. But this point right here. Now that's a point that's on the line, which means it's automatically included. And we're going from left to right here. So that point is included in my domain. So I'm going to put a square bracket in here. And that x value, well, it's showing it's right on the x number line. That's an x value that's 1. So I put my comma in here. And then this graph is going to go, see how it's pointing to the right here? For both of these, okay? So it's going to go infinitely to the right. Okay, so this means it will never stop going to the right. So this means that the domain will go all the way to infinity. Now this is an infinity symbol. It's just a 8 on its side, however you want to look at it. But that's my infinity symbol. You can just do an 8 if you'd like, however you do your 8s. But infinity is never included because as a math value, it's too high. So math people, we can't actually include it because it's a value that's changing all the time because it's always going up. Okay. So infinity, it can't be included in, or it can be in the domain, but it's not included, or the range. Now think about this. If this line were flipped, right? So let's say it was kind of going like this, then it would start over here as far to the left as you can go, which is negative infinity, and then it would have stopped at 1. Okay, so it just kind of reverses this, but you can have negative infinity in the front. So you have to be careful with that. So the range then. Okay, so the range, that's y values, which is, we'll say lowest upwards. It's our y values. All right, now these arrows, we can see that this so I'm going to start at the low. This graph is showing that it's going down right here. Now, where does it stop going down? It never does. Okay, which means that this goes all the way down to what we would consider negative infinity, which is a value we can't define as math people. So the range would say it goes as low as negative infinity. Okay, now infinities are never included, so it's always a parentheses here. And then we'll split this up. How high does it go? Well, this arrow up at the top, it is, some students would say it's only pointing to the right. No, it's kind of going up and to the right. So it will go infinitely upwards, which means that it's going to go as high as infinity. So it's never stopping going down or up, which means we'll just put infinity here. And again, either infinity, whether it's negative infinity or positive infinity, never included. So this is our actual range on this one. So domain is x values. This is left to right. Range is y values. That's low to high. Bottom to top, however you want to say it, okay? Let's start with the domain. So I put these arrows on the end so that we can tell that this pattern continues. Now the pattern continues, meaning that what we're not seeing here is that this line just continues upward in this direction. And then this arrow is saying that it points in this direction. That is not what these arrows are saying. The arrows are saying that the pattern continues, meaning the pattern, which is, I'm going to call that a squiggly line. Let's see if I can do it. You know, something like this to the left, and then something like this to the right. But those suck, so I'm going to get rid of them as well, okay? But the pattern is this squiggly line, meaning that what you see is what you get forever. So, my domain. We look at this. That's left. So we look at this graph. We say, how far to the left does it go? Well, it's showing an arrow here on the left, meaning that eventually, to the left, this will go all the way to negative infinity. So my domain starts at negative infinity, which is an unquantifiable value, so it's not included. We put parentheses in there. We never use square brackets for infinite values. Now that's as far to the left it goes, right? So as far to the left, infinity, eventually I'll get you here, and then it squiggles. Again, this is going to tell us that it squiggles to the right. But again, this arrow is telling us that to the right, it will go forever as well. So to the right, this one also will go all the way to positive infinity. So comma, positive infinity, and infinity is never included. So that would conclude the domain on this problem. So again, a little bit new for us, right? This one goes from negative infinity to positive infinity, a little bit like the last one, but it was the range that was negative infinity to positive infinity. This one, the range, so now I'm looking at down to up, low to high, start at the bottom, going upwards, however you want to say it. The range, that's my y values. So the lowest point that I can see on my graph, I got this point right here and this point right here. Now some students, because we're used to math people being jerks about this, they say it's not -1, it's negative 1.05 or some crappy thing like that. No tricky business here, all right? Both of these low points show, like this is my low point, that this low value is -1. Okay, so my range is going to start at a low of -1. But in addition to that, these low points are on the graph line here. And since it's on the graph line, it means it's automatically included, meaning that for my -1s, I now have a square bracket. So that's going low. I'm going to go to my highest point, which the highest one that I can see is this point. Okay, again, these arrows do not indicate that this is going to go forever upwards in either direction. But that is already next to the y value, the highest value, which is 1. So we'll put this here in my range. So it goes from -1 to 1. But again, this 1 is on the line, so I'm going to include that in my range. So I have square brackets both for -1 and 1, which means all the values between these and including them are part of the range, which means you include negative 0.99999, you'd include 0, you'd include 1/2, 2/3, anything less than 1 but greater than -1, however you want to say that. This is my range. And yeah, we found this was my high point right there. So we've seen this before. If it's positive, if a graph is considered positive, it has to be completely above the x-axis. This is only its relationship to the x-axis for all three of these. If it is negative, then it has to be below, only below the x-axis. If it ever crosses over the x-axis, it is both. Okay, so a graph, it is possible for it to be considered both. What they may pull on the assignment is they're going to give you these three options, positive, negative, or both, and then they're going to say none. None of these, or something like that. If you choose none of these, we know you weren't paying attention in class. And then we know maybe you just like to sleep in class, which is fine, right? Because that's an adult decision. But just keep in mind, they may have a fourth option on the assignment. It's there to see, if you remember, that these are the only three options. For positive, negative, or both. Okay, so positive, is it all above the x-axis? So let's identify the x-axis first. Boom, I found it right there. It's my horizontal axis. It's not exactly on the line, but that's okay. So I do have, if I were looking at positive here, I've got these points that are above. Okay, so I do have some points above. But in addition to that, I also got these 2 points that are below, which would make it negative as well. Below. And again, above and below, we're looking at the x-axis. We have some points above, we have some points below, so this one has to be both. This one, let's identify our x-axis once again. It's right here. This whole line that we have is completely above the x-axis, which means this one has to be all positive. Or in other words, all these y values are positive, okay? So this line, this graph right here is considered positive. And once again, these points at the end don't matter. Again, they're not going to do any tricky stuff like, actually off the graph, there's a line over here. None of that stuff. This one's above, so it's positive. So on this one, I've got my x-axis, okay? Now I have, part of this line is above. I got this curving part, which is above my x-axis. Now, if that was all that was there, that would be fine. This would be considered positive. But what we see is that part of this line is also below the x-axis. So this one also is both positive and negative. Now, it's happening simultaneously, by the way. That just tells us that it's not a function. We don't care about that. It's not what it's asking. What we do know about this one is that it's both. It's both above and below the x-axis, meaning it's both positive and negative. Let's go through this one here. Here's my x-axis once again. Now, it doesn't matter how much of the line is above or below. I have some parts above, here and here. And of course, this pattern continues, but I have some parts above. Now, that would make it positive, except there's some parts down here below. And again, when we say above or below, we're talking about the x-axis, which we've drawn in green right there, though not so well. But either way, this is still both. So increasing, decreasing, or both. A graph is increasing if it goes up. This has to be, you have to change this in your notes. It says left to right. That's what it should be. Okay, and a graph is decreasing if it goes down from left to right. All of these, increasing, decreasing, or both, this is always in relationship to from left to right. Now, the reason that is because if you go in the wrong direction, then you may put in the wrong thing. For example, an exponential graph that we've seen in the past, something that looks like this. If you go from left to right, then you see you'd go downwards on this graph. And so this one would be considered decreasing. But if you had switched it, and if you'd gone from right to left, then you see you would have gone up. And you may have said that this was increasing if you went in the wrong direction. You have to go in the correct direction. It's from left to right. Now, the other thing we'll see is that some graphs both increase and decrease, meaning that sometimes they go up and then they'll change directions and go down. Sometimes they'll go down and then they'll change directions and go up. Doesn't matter which one it is. As long as we see a graph that changes direction up and downwards, then we know that it can be both. So if a graph is increasing, decreasing, or both, that's what we want to know on this one. But what I see is, I know that I have to go from left to right. So since I am going from left to right, what I'm going to do is I'm going to start at my leftmost point, which is this one right here. That's at -3, -4. And I'm going to move to the right. Even though there's only points, what I'm going to do is I'm going to connect them as I go to the right. So as I go to the right, I would get to this point. And then going to the right, the next point is up here. Sorry, that line's not so straight, but I'm doing my best. And then further going to the right, I get here. And then I would come to this point, and then further to the right, we have this one. That's the rightmost point that we have. Now, we just think about the direction right here. And you could say, well, from the first point to the second one, it's just a straight across line. It's not really increasing or decreasing. That's fine. But then we see that the pattern is showing that it is going upwards to the next point. And then it's flat, and then it continues upwards once again, and then flat again. Now, the flat parts I don't really care about, but what I do see is that I have sections going up in these two sections right here. So for this problem, I would say that this one is increasing. So again, this is always from left to right. Yeah, we're going from left to right, and the leftmost point that I have, this one. And so as I move along this line, I see that it is going downward. Now again, this would also be a slope thing since it's going down. It would have a negative slope, so this one would indicate, no matter how you look at it, that this graph is decreasing only. Now if by chance it changed direction, it would be both, but this one's just decreasing. Okay, this one, increasing, decreasing, or both. So from left to right, this is my leftmost point right here. Now, if I go to the right, if I can follow the line up this way, so this would indicate that it's increasing. But if I follow this part of the line, I would go down as well. Now, it's not normal for this to happen simultaneously, but I'm both increasing and decreasing. Doesn't matter if it happens at the same time. It doesn't matter if it happens separately. Again, this is both. So this line, we are expecting it to go from left to right. We're going to scan it from left to right, or start as far to the left as we can go. Of course, we know this one with the arrows, it goes to negative infinity. But as far to the left as we can go, That'd be this point, but I see starting out, it's going down. Now down would indicate that this one is decreasing at that interval, but then it gets to the bottom point right here, the vertex, not that you care about that, but then it switches directions and then it goes back upwards. Now whatever it does after this doesn't really matter, we just see that it went down and then up, so automatically as of right now it's both. Even though later on it switches directions again and it goes down. And then even later on it switches and then goes up. But it's continually alternating between going down and then up. It's a wavy or curvy line, however you want to say it. That wavy I think might be best, but this one's both. So this is all our new vocabulary on this one. We have continuous and then we have discrete. Really the only thing we're looking for this one is a line. If we can see a line anywhere on the graph, it's considered continuous. That's it. A graph that has a line. If it's discrete, there is no line. That's another way to say this. But what you'll see is just that it has just ordered pairs or points that are on the graph. So the moment we see any type of line, it would be considered continuous. Or it may have dots on the end. We don't really care what's on the ends of the lines. You can have dots on the ends, but as long as there's a line connecting the dots, it's considered continuous. Or if there's arrows at the ends of the lines, we don't care about those either, because it means that the line is, well, continuing, so that therefore it's continuous. So discrete means you're just going to have individual ordered pairs as you go. So when we look at a graph like this one, I only see ordered pairs. This one, another way I'm going to say this is that I don't see any line, no line. What I do see is a bunch of points, which means that automatically this one, discrete. For this one right off the bat, I see a line right here. There is a line. In fact, I'll put is a line. So this one would be considered continuous. So this one's the same thing, what I notice. And it doesn't have to be like the last one was a straight line. This one's, it curved, right? So I see some curviness. Doesn't really matter. What I see is that I see a line. No matter what kind of line it is, it can be a straight line or a curved line. Either way, it's continuous. Here we got this wavy line. Again, I don't even see any ordered pairs on here, and it wouldn't matter if I went onto this line and put these arrows at the end. I don't care about the end points or the arrows on the ends. All I see here is that I have a line. That's all I need to say that this one is continuous. There's our objectives again. We looked at domain and range in a new way, right? Because some of these domain and ranges went from negative infinity or all the way up to positive infinity. We saw increasing, decreasing, or both. We got positive, negative, or both. And then continuous and discrete. Those are our new vocabulary words. Of course, we did see increasing or decreasing, but we saw that it could have been both. But remember, increasing or decreasing is always from left to right.